Who recovers from childbirth faster? A randomly selected sample of 16 insured women spent an average of 2.4 days in the hospital for a routine childbirth with a standard deviation of 0.62 days. Another randomly selected sample of 16 uninsured women spent an average of 1.8 days in the hospital for a routine childbirth with a standard deviation of 0.53 days. Find the 98% confidence interval for the true mean difference between the amount of time spent in the hospital after childbirth for insured women versus uninsured women. Do not assume equal variances. Is there a significant difference? All right, so when I look at this problem, I see that there are actually two sets of sample data, right? There are 16 insured women in the study and 16 uninsured women, so two separate sets of sample data. The other thing I notice is that those sample sizes are small. And finally, that they're asking us to do a confidence interval. So I'm going to say this is a two-sample t interval. Two samples, obviously, because there are two sets of women here being looked at. And then the fact that it's a confidence interval tells me it's an interval. And since the sample sizes are small, I know it's a t interval. So in my calculator, I'm going to press the stat key. I'm going to go over to where I see the calculate menu. I'm going to scroll down from there until I see something that says two sample t interval. So let's keep going. All right, and you see it there. You see this number 0 here, the two sample t interval. So I'm going to take that option, and when I'm in there, I'm going to be looking or being asked first whether I'm using data or stats in the problem. Data would mean we had the list of the 16 insured women time spent in the hospital and the list of 16 uninsured women's time spent in the hospital. But I don't have all of that, right? I just have the sample mean, the sample standard deviation, etc. So I don't have in each of these problems all the data. I just have the summary values. So I'm going to go ahead and select stats. That's where we use the summary values. Of course, if you just scroll down, you can see what they're asking you, and if you have that stuff, then you can use that setting, so you don't have to remember which one you should use. But basically, most of the time, it's statistics. All right, then the first thing they're asking for is a sample mean for the first population. So let's use the insured women as the first one here, and the sample mean, it says, is 2.4. So let's do 2.4. The standard deviation here in this case is 0.62, so 0.62. Then scroll down there and you have the sample size for the first population, that's 16. Then you come down to the second population looking at their sample mean. It says their sample mean is 1.8. Their standard deviation is 0.53. And then scroll down and ask us for the sample size. Again, that's 16. Okay. Now, the confidence level in this problem is 0.98, so we'll type in 0.98, 98% confidence level. And then it's asking us whether we should pool those sample variances to get a single pooled estimation of the variance. And when we look at this statement here, it tells us what to answer. So this negative statement here, do not assume equal variances. The do not, you can remember that goes with no for the question of pooled variances. If we don't want to assume they're equal, we do not pool them together, so we say no. Then come down here, hit calculate, and you'll get your answer. And the calculator takes a little bit to do this problem because it takes a while to get the critical t value that's necessary for the interval. So it'll come up soon though, and there it is. It's 0.09825 up to 1.10. So the interval is entirely positive, and so if we did the subtraction as we did it with it, we had the insured women minus the uninsured women, it means that the insured women spent longer time in the hospital after they had a baby. That could be because the hospital doesn't mind keeping them around since they're going to be collecting from the insurance company for the work they do and for the time that they spend in the hospital. So if you don't have insurance, they're probably trying to rush you out of the hospital as fast as possible to make room for a paying customer. Okay, so that's basically the results of it, and you get the degrees of freedom in the problem, which is nice because degrees of freedom are hard to come by with this procedure. If you're going to be using the Welch-Sadgerweight approximation method, it's difficult to come up with that degrees of freedom. Here, the calculator gives it to you. And if you scroll down to the bottom here, you'll also notice that you have all the summary values that you entered in originally. You would just check those to make sure you enter them in properly to confirm that your interval is in fact correct. And that's it.